The first formula to find the angles in polygons is the sum of the interior angles. If I look at polygons, if I take all of the interior angles and I add them together, the more sides I have, the larger the sum of the interior angles. The formula to find the sum of the interior angles is the number of sides of my polygon minus 2 times 180 degrees. Now if this gives me the total sum of the interior angles, if I want to find one interior angle and I have a regular polygon, I'm going to take my total and divide by how many sides I have. The number of sides is going to be the same as the number of angles. So to find the measure of one interior angle, I'm going to take the sum of the interior angles and I'm going to divide by the number of sides. Next, the sum of the exterior angles. Well, an exterior angle is formed by extending the sides of my polygon. So if I extend the sides of all of my polygons, I've created my exterior angles. To find that sum, I need to think about my exterior angles this way. In a triangle, I have 3 exterior angles. And if you look, the exterior angles go all the way around my polygon. In a quadrilateral, there's 4 exterior angles. And those 4 exterior angles go all the way around my polygon. In a pentagon, there's 5. They're a little bit smaller, but they go all the way around. So the sum of my exterior angles, no matter what polygon I have, is always going to be 360 degrees. And kind of like if I want to find, kind of like when I found the measure of one interior angle, to find the measure of one exterior angle, I'm going to take the total and divide by how many sides I have. How many sides will be the same as how many angles. That only works for a regular polygon. So I'm going to take 360 degrees, the total sum of my exterior angles, and divide by the number of sides, n. Let's take a look at some examples that use these formulas. A regular polygon has 6 sides. What is the measure of each interior and exterior angle? Well, I know the number of sides is 6. So to find my interior angle, I'm going to take the number of sides minus 2 times 180 and divide by the number of sides. So I'm going to take 4 times 180 and divide by 6. So the measure of one interior angle of a regular hexagon is going to be 4 times 180, 720, that's the total interior, divided by 6, gives me 120 degrees. To find my exterior angle, I'm going to take 360 degrees and divide by the number of sides. When I do that, my exterior angle is going to be 360 divided by 6 gives me 60 degrees. If you notice, the interior and the exterior angles are going to be supplementary. If you look at your polygons, an interior angle and an exterior angle will form a linear pair, which means that they will be supplementary. Example number 2. A regular polygon has an exterior angle that measures 40 degrees. How many sides does that polygon have? Well, I have to do this problem a little bit different because I'm given an exterior angle. So that's the formula that I'm going to start with. The formula for the measure of an exterior angle is this. An exterior angle is going to equal 360 degrees divided by n. And I'm going to plug in what I know. I know that my exterior angle is 40 degrees. The piece that I don't know is n, the number of sides. So I have this equation where I need to solve for n. And in order to solve for n, I'm going to cross multiply. So I have 40n equals 360 degrees. Divide by 40, divide by 40, n equals 360 divided by 40. 9. So my polygon that has a 40-degree exterior angle is a nonagon. It has 9 sides. Last example. A regular polygon has an interior angle that measures 135 degrees. So I know the interior angle, and I need to find out how many sides that polygon has. Since I know the interior angle, that's where I'm going to start. I'm going to start with the measure of one interior angle formula. N minus 2 times 180 all over n. And I'm going to plug in what I know. I know that my interior angle is 135 degrees. And what I don't know, my unknown, is n, the number of sides. At this point, I'm going to cross multiply to solve. 135 degrees times n equals n minus 2 times 180. Keep solving for n. I'm going to distribute on the left side. 180n minus 360. Subtract 135n from both sides. Add 360 to both sides. Divide both sides by 45, and I get n equals 8. So it's an octagon that has an interior angle of 135 degrees. I knew what my answer had to be, so I plugged what my answer had to be into my formula, and I solved for my unknown by cross multiplying.